welcome to my YouTube channel. What is sp hybridization? The structure of alkynes can be explained by yet another mode of hybridization called sp hybridization. In this type, 1 2s and 1 2p orbitals of the carbon atom mix together to give rise to two degenerate sp hybridized atomic orbitals. These orbitals have a linear shape with a bond angle 180 degree. The two unhybridized atomic orbitals 2py and 2pz are perpendicular to these sp hybridized orbitals. Ethine molecule is formed when two sp hybridized carbon atoms join together to form a pi bond and sp-sp overlap. The other sp orbital is utilized from a sigma bond with one s orbital of hydrogen atom. The two unhybridized p orbitals on a carbon atom will overlap separately with the p orbitals of the other carbon atom to give two pi bonds with both perpendicular to the sigma framework of ethine. The presence of a sigma and two pi bonds between two carbon atoms is responsible for shortening the bond distance. Why is ethane an important industrial chemical? Importance of ethene. Ethene is used for the manufacture of polythene, a plastic material used for making toys, tables, bags, boxes, etc. For artificial ripening of fruits, as a general anesthetic, for preparing mustard gas, as a starting material for a large number of chemicals of industrial use such as glycols, antifreeze, ethyl halide, and ethyl alcohol, etc. What is isomerism? Two or more compounds having the same molecular formula but different structural formulas and properties are said to be isomers, and the phenomenon is called isomerism. The structural formula of a compound shows the arrangement of atoms and bonds present in it. The isomers have different physical properties. Types of isomerism: structural isomerism, geometric isomerism. Structural isomerism. The structural isomerism arises due to the difference in the arrangement of atoms within the molecules. The structural isomerism can be exhibited in five different ways. These are the chain isomerism. This type of isomerism arises due to the difference in the nature of carbon chain. Position isomerism. This type of isomerism arises due to the difference in the position of the same functional group on the other carbon chain. The arrangement of carbon atoms remains the same. Functional group isomerism. The compounds having same molecular formula but different functional groups are said to exhibit functional group isomerism. Metamerism. This type of isomerism arises due to the unequal distribution of carbon atoms on either side of the functional group. Such compounds belong to the same homologous series. It is due to the presence of different alkyl groups attached to same polyvalent functional group or atom. Tautomerism. This type of isomerism arises due to shifting of proton H positive from one atom to the other in same molecule. Amino acid is converted into zwitterine and acetaldehyde is converted into vinyl alcohol. Cis-trans isomerism, which is also known as geometric isomerism, is those compounds which possess the same structural formula but differ with respect to the position of the identical group in space are called cis-trans isomers, and the phenomenon is known as cis-trans or geometric isomerism. Two carbon atoms joined by a single bond are capable of free rotation about it. However, when two carbon atoms are joined by a double bond, they cannot rotate freely. As a result, the relative positions of the various groups attached to these carbon atoms get fixed and gives rise to cis-trans isomers. Necessary conditions. The necessary and sufficient condition for a compound to exhibit geometric isomerism is that the two groups attached to the same carbon must be different. There are examples: C4H8, cis-2-butene and trans-2-butene, C5H10, cis-2-pentene, trans-2-pentene, C3H4BrCl, this is cis and that's trans, and both are 1-bromo-2-chloropropene. In the cis form, the similar group lies on the same side of the double bond. In the trans form, the similar group lies on the opposite sides of the double bond. The rotation of two carbon atoms joined by a double bond could happen only if the pi bond breaks. This ordinarily costs too much energy, making geometric isomers possible. Necessary condition for that question is the necessary and sufficient condition for a compound to exhibit geometric isomerism is that the two groups attached to the same carbon must be different. The above structure shows that one butene double doubly bonded carbon atoms contains two similar atoms attached to one side, so unable to show geometric isomerism. On the other hand, 2 butene does not show 2 butane 2 butane does show cis trans isomerism.